We've now reached the start of round 20. If you spell this next word correctly, we will declare you the National Spelling Bee champion. It's a noun. It's from an originally German word.
The word is SINUMERIK.
SINUMERIK. SINUMERIK. SINUMERIK.
That is correct.
Congratulations, you are the National Spelling Bee champion.
The storm is coming.
Welcome to the TRAK video event. I don't know how these machines work, but I'm going to introduce you to people who do.
Do you mind?
Introducing the TRAK VMCsi, featuring the all-new SINUMERIK ONE by Siemens. The world is changing.
From a features and capability standpoint, specifications, the customer is getting a product of tremendous value and a product that, from the time it hits his floor, he will be working with an excellent production control with outstanding productivity features. So the customer gets immediate value, and he also gets value far into the future. And honestly, I can't say that it makes sense to buy any other product.
I was initially shocked when I heard we were teaming up with Siemens. Traditionally, TRAK has always, from start to finish, made our own products.
When I first found out that we were going to develop and sell VMCs and turning centers with the Siemens control, it was a very exciting time. It was exciting, number one, because it was part of the growth plans that we had had, but more importantly, it allowed us to give our customers a full complement of products, from tool room to production to technology adoption.
The first time I heard it, to be honest with you, I was like, well, what are we doing that for? You know, we have a great control system. We've spent a lot of years developing it. We're all very proud of it. We don't need Siemens. But then I came to understand the market we want to move into is very competitive. There's a lot of new technologies there. And yeah, we can probably get there, but it might take us 10 years to get there. And we can't wait 10 years. Having that partnership now really opens up a lot of doors for us.
Siemens brings to the table the platform. So the hardware, the software, the connectivity, the cloud computing, so all that's within the Siemens platform. It's going to be up to us to take that platform and write specialized software from our perspective for our particular market segment, and also create machinery to take advantage of all that.
We at TRAK look up to Siemens as a leader in transformative technologies. Can you tell us about Siemens' vision for manufacturing?
Yeah, so our vision for the future is we want to really embrace digitalization and embrace the digital thread. It's been an excellent teamwork, excellent collaboration between my team and between Steve's team, coming together really with a mindset to get it done and to meet all the milestones of this project and get these machines launched.
Working with the TRAK engineering team is very rewarding. They're smart guys, eager to learn. They know all the right questions to ask.
Siemens as a company, they embrace innovation. So there's always progression. There's always, moving forward in terms of where technology is going.
So we're a very big global company, over 385,000 global employees. Here in the US, we have around 60,000 employees, around 80 to 100 billion in revenue every year. We've been around for 160 plus years, and we're a company that thrives on technology.
The interactions that I've had with Siemens so far have been positive. They have an extremely talented organization, wealth of knowledge.
I think it's gone very, very well. Siemens is a big organization. They've got a lot of engineers, a lot of resources, and so I've gotten the chance to work with a number of them. Very smart people, They've helped us along the way, educating us on what their product's all about.
I actually had a number of discussions with TRAK 18 years ago, and this partnership between TRAK and Siemens really brought the best out of both companies.
To have Siemens backing is tremendous. They're a giant in the industry. I don't know if there's a better partnership we could have.
Back in the late 70s, we transformed our production machine shop from manual machines to CNC machines. And in that process, we got an enormous increase in productivity. A few years after that, it became apparent that while we got that productivity in our production area, our tool room area, we had 5 tool room machinists at that time, their productivity had gone nowhere. They were using the same equipment that they had been using 30 years prior.
We and our customers face a future where the world looks very different than it does today. And it doesn't take a lot of imagination to see that the changes that we've seen in photography and music and retail, these huge disruptions, changing those industries beyond recognition. These changes are headed for manufacturing.
What we did was to take the CNC technology that had become common in production areas and simplified it and made it much less intimidating to skilled machinists who were in their mostly 50s and 60s to be able to utilize and embrace.
What parallels to that innovation apply to the initiatives we're talking about with new technology?
What is needed today and what we can provide is a transition from CNC technology that people have today to this new technology of company integration and automation. It's really the same as what we did in the past and continue to do today, except it's just another step from CNC to integration and automation.
So continual expansion.
It's a continual process. All of this productivity improvements and improvement in manufacturing it's not a destination. You don't get there and then you're there. It's a journey. You have to get better and better as time goes on.
That's good advice for anything.
It's a good advice for everything.
We're here in Cromwell, Connecticut, demonstrating the new Siemens SINUMERIK ONE control on the TRAK VMCsi, featuring Shopmill conversational programming right on the shop floor.
Today I'm going to be showing you how to use the conversational Shopmill programming to program the features of this part. Let's see what the complete program will look like when it is all finished. This is the program summary screen. One of the things that makes the SINUMERIK ONE so intuitive. Here you can see all the elements of your program all in one place. If you want more detail, just tap the element. Let's see how easy it is to program the features of this part.
We're going to start right up at the top of the circle. That's X0, Y positive 2.45. And now we're going to wrap around to the bottom of the arc, so I'd simply tell it, give it an arc. We choose the direction of rotation. We tell it our radius, which is 2.45. We give it our X value, 0. And our Y value is that negative 2.45. Everything else the machine's going to calculate for me automatically. I can just hit accept. Now this line right here is going to be at an angle, so I choose that angled line, and we're moving over to Y. X equals 3.064 negative, Y equals 0.4045. So X, negative 3.064. Y equals 0.5405. Type that in. Again, it calculates everything for us. Enter in the radius. Now, we're not going to a sharp corner. We need the machine to blend that radius for us. We have a transition to next element. We simply tell it there's an 841 radius, and the machine's going to do all the calculation for us. Simply draw the last angled line. X is going back up to 0. And Y is going to 2.45. Input, accept, our profile's complete. And now we want to cut the pocket in the middle while we got the end mill, right? So we're going to go into milling, pocket, we choose circular pocket, and then we choose our tool. Well, we're going to use that same 3/4 inch end mill, so it's already populated right there in the control for us. We're going to cut it 30 inches a minute, 2500. We're going to do our rough machining. We're going to do it centric. We're going to define this circular pocket based on the center. We give it our X, Y, Z, 0, the diameter of our pocket, which happens to be 1.5. We've got our Z -1, that's our minus 100,000th depth. We're going to go at 70% cutter step over. All of that looks good. We're going to do a helical entry on this where we can adjust the pitch and the radius of the helix. And there's our circle pocket. Now from here, we're going to be doing our bolt hole pattern. We're going to switch over to our center drill now. And so we're going to do our centering. So we've got our center drill. We've got 10 inches a minute, 2,500 RPM. And now I tell it, where are we going to do those center drills? Give it a position, simple picture. I pick the bolt hole pattern, and now I simply tell it where I want those holes. Z starts at 0, X and Y, right on center. Our first hole is at 45 degrees, and the radius of that bolt hole pattern is 1.25 inches. I've got 5 holes. So now the last thing that we need to do is we need to drill the 1/4 inch holes on the bolt hole pattern, right? So that's as simple as go to drilling and tell it we want to drill. Well, there's our drill 250 right there in the list. Okay, 10 inches a minute, 2,500. Now I can do it by the tip or by the shank, so it's going to automatically figure out, and I can enter into my tool library what the actual tip angle is, and it will automatically calculate how deep, how much further it needs to go in order to get to the shank diameter. So we'll go all the way through minus 1/2 inch, no spot drill. And then I can take this same bolt hole pattern I used for the center drill and simply copy it and paste it below the drilling. And we're done.
Tell us about the SINUMERIK ONE. What does this mean for the Siemens product line?
Wow, so the SINUMERIK ONE is a big step forward for Siemens in our capabilities. And it's really the next in a series of controls that have really driven technology in the market.
The biggest thing is it's just so flexible. It can do so many things. The world is kind of your oyster. You can have it run on any kind of machine. It can be configured a lot of different ways. It's very conversational. You walk up to it and it's intuitive and easy to learn.
The SINUMERIK ONE was designed as the first digitally native CNC controller, as a virtual CNC controller, and of course as a real CNC controller.
Siemens has developed the SINUMERIK ONE to be relevant far into the future in 2 different ways. First, this concept of the digital twin. The SINUMERIK ONE hardware and software has been designed explicitly to work with the digital twin. And this digital twin concept is an important concept today, but it'll even be more so in the future as connectivity and automation and other software products evolve wrapped around this idea.
It really is an accumulation of 6 decades of development. And if you take the combination of the software optimization and taking the latest generation of hardware and combine those 2 together, you really do get the highest performing CNC controller on the marketplace today.
The key thing that you get with the SINUMERIK ONE platform is access to the digitalization tools. So that includes the digital twin, that includes the MindSphere and being able to access and manage the machines remotely. These are things that are definitely going to give you increased productivity.
Secondly, the SINUMERIK ONE is a relatively open platform, and that means Siemens is going to continue to develop applications, but other developers can build applications as well in connectivity, automation that will work on this control, and we are one of those developers.
We want to push the envelope of what is possible, and we think that that's really what's been driving advanced technology. And the SINUMERIK ONE is really doing that, especially in the digitalization portfolio or the Industry 4.0 world. It's allowing us to incorporate functions that traditionally couldn't be in a CNC control in this new open platform.
On the machine side, the main thing is simply performance. We bought one of their controls 15 years ago. We have a test program called the Ball Bar, and it had the best one I've ever seen. And I've checked our own equipment, I checked some of our competitors' equipment, and it was like the best one I've ever seen. And so when the opportunity came up, I said, you know, if we go with Siemens, I already know what I'm going to get for machine performance.
What Siemens does is it has a very innovative approach where we look at polynomial curve fitting. And what that means is we can take tens or hundreds of points, put a high order polynomial through there, and then instead of processing 100 blocks, you're processing one algorithm. It not only decreases the amount of data that the controller is trying to process, but it also smooths out the paths. So you get better surface finishes, and you also get reduced cycle times.
It allows parallel design work. For the machine builder, they can do parallel engineering. For the end customer, they can do parallel part programming or parallel resource management.
Most controls, they kind of give you one way of running the control, one way of doing a task. So the consumer has to fit their process to how that control works. In the SINUMERIK control, we give you a bunch of different ways to actually apply the technology. So we allow the control to adapt or fit to the customer's processes, not necessarily making the customer fit into our box. All right, so now that we've done a little bit of conversational programming, let's take a look at CAD/CAM based programming.
Great.
So what we're going to do is we're going to do a 3D surface cut. I posted it from my CAM system. It's sitting on our USB device. And we're going to go and take a look at editing, but I'm going to leave it on the USB device the whole time. So not only can we edit on it, we can actually run directly from the USB device.
Great.
So come over to your program manager. We'll see our local storage, and then you'll get your USBs. So when you come in, we're going to open it up and edit it just as if we were programming or using a file that was sitting on internal memory. So find the program you want, just hit the little arrow open, voila, we're in.
All right, so I'm looking at a G-code program, but the screen looks almost identical. My horizontal and vertical soft keys look identical to Shopmill.
Absolutely. So intentionally, we wanted to keep the placement of all the functions in the same exact point. So from a new user learning perspective, they're not going to have to learn a brand new layout just because I'm in G-code. So if I wanted to mill a pocket, I can go to milling, go to pocket, and you notice
it's exactly the same.
Not only exactly the same, it's conversational, right? So our G-code is actually a hybrid. So it's conversational and G-code combined. So here you could fill out that page, an end user could drop in some numbers and actually modify the G-code file from the control.
Okay, I'm looking down here, I'm seeing that we're at line number 22,307. Now, but the program doesn't look that big.
Right, I mean, we look at it, we're like, well, it's barely a page of data. I mean, boom, there's our M30.
Right.
So one of the things we like to do is we like to use these groups command. Now you can use groups in Shopmill, we can do it in G-code, or you can even have the post do it. And what I do is I like to be able to add or subtract large chunks of code from my CAM system. So like, what do you really want to know? You're an operator, you walk up to the machine. Do you care what's happening on line 3022?
Absolutely not.
So what do you want to know?
I want to know my work offset coordinates, I want to know my speeds, my feeds, my tool that I'm using.
So we put up that right outside the group, so I can get a quick snapshot and see multiple operations all on the same page.
Right.
Then if I want to get into the meat of it, we certainly could.
Yeah.
When we're in 3D, this is a touchscreen. You'll notice I'm hitting the screens. So not only is it a touchscreen, it's a multi-touch screen.
Okay.
So just like that cell phone you got, I can come in and I can do 2-point gestures, I can rotate, spin, or I can just use a single point to pan. So we have a whole bunch of organic functions that most users are already used to, because it's just like they're interfacing on their phone and their tablet, but here it's at the CNC. See, it's important for us to set up the technology in something that's really common to people.
Yeah.
Right. So we like this concept of applications, so we add in all these cycles, almost like it's of an app.
Right.
We added the touchscreen functionality.
Yeah, it's just intuitive.
Yeah. Now, even in the editor, we added some of the multi-touch functionality.
Okay.
So here I can kind of scroll and move around the part. But I have, as you saw before, what was it, 22,000 and something lines?
Yeah, finding something in there is going to be a nightmare.
Well, what if I want to get to M30? Maybe my retract is not where I want to put it.
Sure.
Well, that's only at my M30, right? So that's always a pain. How do I get down there?
Yeah.
So if I use 2 fingers, it will page up and down a page. If I use 3 fingers, we'll go right to the end of the program or the beginning of the program. So we just spanned 22,376 lines in the swipe of 3 fingers.
That's terrific. And then if I'm looking for a specific tool information, I want to jump between all my different tools, check my speeds and feeds. I see a search button right there.
Absolutely. Search does 2 things. Allows me to get to some text or data that I know I want to find. Maybe it's a T or an M code. But I can also do search and replace. So, you know, you got that program down from the CAM system. What do they always like to do with feed? Program feed everywhere, right? You got 1,000 feed commands. How do you edit that at the control? You normally can't. Find and replace, boom, it updates all 1,000 feed rates and away you go.
My name is Pat Fitzsimmons and I am the West Coast Regional Applications Representative. I'm better known around as Tracking Pat, which is kind of my stage name now. I've been with the company for 23 years. When I'm at a trade show and people actually recognize me from the YouTube video, it is kind of exciting because they'll come in and want to talk to me first and thank me for the videos and tell me stories about how they've really helped them. So that part of it is really, really exciting. When you get that opportunity to call on someone to help someone, you build a relationship. When you see somebody like that you haven't seen for a while, but you know they've benefited on the things that we've done for them, I enjoy what I do and it makes it really fun. And at TRAK, they let me be me. Don't forget, keep on tracking.
And cut. That was good, Pat.
Of course it was. The world that we live in now, manufacturing, is getting more and more complex every day. And we know that our customers need a partner that can help them navigate these complexities as they move forward.
Working with their sales organization, it's not at the end of the day, you know, if I can sell this one machine into this customer. It's really, can I be a partner for this customer? You look at the history of TRAK and how long that company has been around and innovating and taking care of their customers. You look at Siemens. Siemens has been around for hundreds of years. That combination of TRAK and Siemens that's going to be there for the long run is not just an investment in the machine tool, but the investment in the companies that are going to support your machine tool.
Customer service, customer satisfaction, that's what we're known for, and that's what we embody. From field service and sales to manufacturing support, service is key. So if you're shopping for capital equipment, obviously one of the first things is, what's your service like?
TRAK Machine Tools, one thing that definitely stood out to me immediately was their focus on service. They have a very extensive service organization and they believe that following through on their service of the machines is what creates their reputation and keeps their customers loyal.
As a sales support rep, I get to work really closely with our sales reps, and they are all an incredibly knowledgeable group of people who really, truly do care for their customers and everyone that they really get to interact with when they're representing TRAK Machine Tools.
We've got very good training programs. We continue to build on those things. There's some gentlemen behind us in that room over there that are doing nothing but writing technical documents, procedures, things like that. So when we bring people on, we have materials to give them. Because we do have a wide range of products. The Siemens now adds to that. And so we've got to be really organized to be able to present that and give that to everyone else.
What application support does Siemens offer its customers?
So Siemens has a vast staffing here in the US. We have well over 100 employees that are supporting all segments of our business space. Certainly from service technicians based throughout the United States that can be here to aid TRAK. We have applications engineers for the physical programming and operation training of the control. We have a full staff of engineers that actually will help integrate the product to the machine tools. So we're here really to support where there's a need for us.
I think it's definitely changing with the digitalization. And I think a lot of that has happened within the last maybe 5 years or so. So I feel like we've always kind of been on this upward trajectory, but in the past 5 years, it feels like, to me, kind of an explosion.
Now in the past, we had been really good, highly proficient in the area of the tool room market, and we understood that better than anybody. But as we reached beyond the tool room and into new technologies, we needed to have people that understood the specific areas, and we needed to divide those specific tasks up between task specialists.
The fact that we're the size we are and that we are privately held gives us the ability to be more flexible and really take customer service to a higher level.
We've gotten some feedback that Siemens customers have been disappointed with spare parts deliveries in the past. How will this be different moving forward?
Between TRAK and Siemens, we're going to come up with a program for guaranteed parts availability for their specific machines, so that we can offer, world-class support, world-class availability of spare parts for these machines.
We have several showrooms across the United States. We realized that the industry was having less and less trade shows. We were unable to get the reach that we wanted through the trade shows anymore. We also recognized that it was in our customers' best interest to see the machines and have us do demos on them live before they made their purchases.
We've been doing it for a long time, and the fact that we support products that are from the beginning of the company says a lot about our customer service, I think.
Skilled, talented, driven individuals that work for our organization. They're true believers in our product and the impact that our product makes on our customers.
I really think that TRAK believes that their customers are part of their family.
Every person in the company has a role in customer service.
So if I go to simulation, you're going to see on here that it's going to actually show me the part as if it's being made for real, okay? So in here you see my block, and you can see that my facing tool's coming in here and wiping out the top of it, right? And then it changes to my 3/4 inch tool, and in here it's doing that first spigot where it's cutting it down to the actual size of the outside, okay? Now it's doing the pocketing part of it, so it's removing the material except for the island. And you'll see that this actually happens in 2 passes to get to my final depth, right? So once it gets it cut out completely here, then it's going to come back and do a second pass like you're seeing right now. Now once it finishes taking the major part of the material out of here, it's going to take that tool and it's going to switch to a little bit smaller tool so that it can get sharper corners on those inside radii, which is what it's doing right now. That's called residual machining. Once it's done with that, that same tool is going to take a final pass to clean it up to the exact size, and then it's going to clean up the floor of the pocket, okay? And that's what you're seeing right now. Once it finishes here with the floor, it's going to actually change to a chamfering tool, and it's going to knock the edges off of all of the surfaces. So off the island, off the pocket, and then off the outside of the part. And that's what it's doing right now. And around the outside like so, and that's the completed part.
You also have real-time simulation. And real-time simulation is a link one-to-one scenario. So as I watch the tool, we'll probably throw it in 3D, that always looks a little bit interesting. We see the cutter, we're taking a look at it. I'm gonna come down and approach. There's the tool. Watch what happened. I stopped the machine, it stopped.
Right, it stopped.
I tried to put the gas on.
Still have my XYZ readout right there.
I can see what's happening right here in real-time simulation. We can still manipulate different points in the view window, all right? I can zoom in. Now you'd say, well, why do you need that, right? I can look through the window, there it is. And we happen to be running dry right now, right? No big deal.
Yeah, you activate
You put blood?
Can't see anything.
Yeah, you know, it's just coolant everywhere. That's what we want. You know, these higher performing machines, they have some really big coolant pumps.
Yeah.
So this, at least I can see not only where I'm at, but what's coming up in the future, right?
Yeah.
So I know, okay, I haven't gotten into the pocket yet. That's going to be coming down a little later.
I'm going to go in and I'm going to actually find the material, all right? So the way that I'm going to do that is, like I said, in here it says measure workpiece. And just so you know, I've already touched off the top of the part, so I'm just going to show you how it touches off the sides and finds it. So there's different shapes in here and different places that I can call my 0 point on my program. But my actual 0 point needs to be off of a right triangle edge, okay? A right rectangular edge, okay? So if you can see in the screen here, it's telling me I basically got to touch 3 places with this probe and it'll figure out where it is. Before I do that, I have to actually tell it what I want that corner to be when I'm finished. And that's where I'm saying my X dimension is -1 3/8 and my Y dimension is -1. Okay, so once I do that and I'm ready to go, this illustration is telling me where to touch the material. Now I've got a handheld device in here that allows me to move the machine around. So I'm just going to come down here in the Z axis and get close. Then I'm going to move it over a little bit here in the X. And then in the Y to get myself in actual position. So you'll see it's asking me to do that. I just push go and you're going to notice that the probe lights up and then it's going to move over until it touches it. And when that light flashes red, it knows where that point is, okay? Next thing I'm going to do is I'm just going to move it over to the second spot. Push go again. It's going to do the same procedure. And then the last thing it wants me to do is touch the opposite side of the part. Now the reason why it's doing that is so that if the vise wasn't perfectly square, it's going to know that by the way it touches the block and it'll still cut the block square even if it's skewed. Okay? So now that I've touched all those positions, I'm just going to move my probe out of the way here a little bit. Oops. Like so. And then here on the screen it says set your work coordinates, okay? So I'm just going to push that button and it's going to zero those points out so it knows exactly where it's at, okay? And now I'm ready to make parts.
The design elements of VMCsi are the rigidity is one of the main reasons why a machine is more precise. The main element that is different from other machines that we make is that it uses roller type linear bearings. They attenuate vibration. They require more precision to make the machine run, but they reward you with the stiffness, the rigidity, the accuracy. We preload and pre-tension ball screws. That gives us zero backlash capabilities. Well, the customer can expect higher productivity, higher quality due to the higher rigidity of the machine, and the spindle RPM and spindle horsepower will allow for heavier cuts, faster cuts.
Now watch this. So you see that cycle 832?
Yeah.
Kind of looks like a little bit of weird kind of cycle, right?
Yeah.
So here's a perfect example of a cycle that was posted from a CAM system, dropped into our control, and it's fully conversationally supported. So if I have to do a quick tweak, I can change my chordal distance, change my strategy, hit accept, boom, I'm running. Don't have to worry about the programming department and downloading those guys.
Tell me, so this is high speed settings, this is a cycle 832. What exactly are we adjusting in this?
So this is a little bit of the Siemens magic going on.
All right.
So this is our high speed functionality. What the control has the capability of doing is taking the point cloud data that comes out of the CAM system and actually transposing a spline through those points and running the spline. So what it does is it gives us a better control of our velocity as we roll over a surface footage. We can maintain a higher rate of speed, and let's say speed is directly going to go to cycle time.
Absolutely.
So that's going to start to cut our cycle time. So to give you an example, this part, we've benchmarked this part in 2 different scenarios, with and without high speed. We had a 30-minute cycle time without. We had a 16-minute cycle time with. Almost a 50% saving in cycle time, just by turning on that cycle.
And with a better surface finish.
Significantly better.
Industry 4.0 is all about the digitalization of the future of companies.
Industrial revolutions happen once every 100 years or so, featuring paradigm shifts in the way human beings manufacture. These quantum leaps are propelled by astonishing technological breakthroughs, which in turn change dramatically the way people interact with machines that make stuff.
The introduction of robotics and all of the Industry 4.0 sectors that are really coming together to create this new shop environment, it truly is a completely different world.
Technology, which not long ago were considered the things of science fiction, suddenly become not only real, but are so quickly adopted.
Automation through machines, all the software that talks between the machines, all that stuff is part of this Industry 4.0.
It causes us to think out loud. What were we doing before this? Transformative technology your shop can use.
Digital twin is taking the machine you see behind me and having it fully modeled up and in a computer, and have all the signals, all the inputs, all the outputs, everything has been what they call digitalized. Oftentimes if you take your part down the machine and it doesn't quite work right, or you crash it or something happens, you're down, you're not running parts, you're not making money.
Digital twin is simply a software representation of a piece of equipment, and allows many different people and groups to participate in the development without having to have that physical piece of equipment reside on your site.
You can now take this digital twin and be very, very confident everything's working correctly, and then go down to the machine and actually physically make the part.
Digitalization, virtual twins and digital twins really improve go-to-market for the machine builder, but also the end customer.
Could you explain the digital twin to me a little bit more? What are the benefits to customers?
Digital twin?
Virtual part.
I should probably know what that is, right?
The digital twin offers...
I wonder what that is.
Alyssa explains the digital twin.
And action!
Digital twins are nothing new. Everything on a computer is digitized. And when that something digitized is meant to represent something in reality, that is a digital twin. For example, this drawing is a digital twin of this real part. These days, digital twins are being used in all kinds of ways. This picture of me is my digital twin, and I can use it to see what I may look like in different hairstyles or clothes. Hi, Alyssa. Oh, hi, Alyssa? When you use the Parasolid feature on your ProtoTRAK, you are using the part's digital twin to make it easier to program and eliminate mistakes by loading the data in directly as the part was designed. Our Verify feature gives you a digital twin of both your part and your tool. This visualization gives you the benefit of seeing how the part will be machined and spot possible problems. Pretty cool, huh? But as good as these benefits are, it gets even better. Siemens has taken this digital twin idea and extended it to incredible proportions. They've invested millions and millions and gazillions of dollars. The efforts of literally an army of top software programmers into a process they call digitalization. And digitalization is the power that happens when you take your work and transform it into the digital world, using software and computer power to your maximum advantage. And this transformation can really help you. How? You can create digital twins of your machines to monitor what is going on with those machines in real time. You can simulate your plan and experiment with fixtures and toolings, adjust your programs, and play with the sequence of operations. As you get better working with your machine's digital twins, you'll be able to optimize cycle times and quality. You'll be able to set up the next job in a fraction of the time it takes to set up and optimize that job on a real machine. This in turn will allow you to keep that machine running at its highest imaginable output, day and night if you want. But what about that extra wear and tear on the machine? Won't it break down more frequently? Good question. There's another benefit of the digital twin. You know how a bearing makes a terrible squeal sound that tells you it's going bad? Well, it turns out there are a lot of those telltale signs throughout your machine. Your digitalized machine will compare itself to its digital twin in real time and tell you what is going wrong so you can prevent a crash or a tragic shutdown. It's easy to get excited about all this, but it's only the beginning. And as that army of engineers working at Siemens gets better at their work, and we get better at making them work in your shop, we can expect some truly amazing things. We're talking about things like artificial intelligence and augmented reality. Right. Imagine getting all that working for you. Those buzzwords aren't just for someone else, you know. Think of this along with your ingenuity, experience, and knowledge of your customers' needs. The sky isn't even the limit for what you can do. As soon as you get your first TRAK machine featuring the all-new SINUMERIK ONE CNC, you are on the path to having the latest technology. It's what we call the path to Industry 4.0. Digital twins and connected machines will become key assets for your shop. So what about those wonderful proto-TRAK machines? Well, that's a good question, Alyssa. As it turns out, those proto-TRAKs have been doing digitalization all along. Because when you use a proto-TRAK, you are digitalizing work that was previously done manually. Over the last 3 decades, we've learned how to help tens of thousands of machinists with what Siemens calls digitalization. As these applications develop, we'll be the first to bring the best ideas to the craftsmen. And women. Of course, and women. Everyone who makes parts in small quantities. And you can be sure that we'll do the hard work of reshaping all those complex technologies to produce real solutions that will apply to what you do, make you more competitive, and add to your success. To get started, you just need to talk to your TRAK representative. We'll show you how easy it is to get on the most powerful digitalization platform in the industry.
Oh, digital twin, yeah!
I've been working with the Taiwanese partners since pretty much the day I started. John Tian is a very ingenious guy. He actually did a lot of the design and initial machinery development. Working with John has always been a pleasure. I think he's one of the people in the generation where they just roll up their sleeves and they go to work. Incredible group of people there, and we work together very well.
What we see in the market space is the shops that are growing with technology are the ones that are succeeding in the market space. So what we've done is we've actually embedded 5-axis programming capabilities right into our control conversationally.
And what's that about is basically being able to run a part complete without having to clamp and unclamp it. So 4th axis gives you peripheral of the part. 5th axis gives you kind of the top plus the peripheral of the part. And so all that's included with the Siemens platform.
So a user can step up from a simpler 3-axis machine technology, move into this 5-axis technology without having to take this large step, bringing in an external programming environment, maybe hiring staff that has to learn it, so they can kind of ease in and use the functionality built into the SINUMERIK ONE to start taking advantage of 5-axis technology without fully jumping in.
The Siemens SINUMERIK ONE has some pretty clever automation functionality built into it. They have a product called Run My Robot Direct, which basically the crux of that is one user interface for both the CNC and the automation functions, which brings to the table simplification of automation. Typically, you have the robot company with their user interface and control, and the machine tool company with their user interface and control. So the poor user has to go back and forth between these 2 platforms. So it's like 2 different worlds and 2 different skill levels to run these things. And so what Siemens brings to the table is the ability to bring that all together as one.
Ready.